Hello everyone and welcome back to the channel. So in this video we are looking at a solution of a test which has questions related to KMM, the kinetic model of matter, and the transfer of thermal energy, including and up to conduction and convection. So radiation is not part of this test. So this is for my school students who have their test tomorrow. So this is a mock test that you were given beforehand to work on, and now we'll be looking at its solution. Let's start. Question number 1, which diagram shows the name of the changes of state that correspond to the directions of the arrows? So solid to liquid is actually melting, not freezing, so it cannot be this or this. And then liquid to gas is either boiling or evaporation, not condensation, which is the reverse process. So it's not this either, and D is the correct one. Question number 2, which row describes the arrangement of particles and the forces between particles in a solid? So arrangement in solids are very regular and the forces between the particles are strong. That's option A. Question 3, which describes the shape of a liquid and the arrangement of its molecules? So the shape of a liquid is not fixed, it takes the shape of the container, and the arrangement, if you think about it, it is more regular than gases, but overall it's not the same repeating pattern. So it's not regular. Question 4. Some gas trapped in a cylinder is compressed at constant temperature by a piston. What property of the gas does not change? So I know definitely if it's being compressed, so volume must be changing. By this relationship, pressure is inversely proportional to volume. Pressure would also be changing. And because the volume is changing, the density would also be changing, but the mass does not change. That's B. Question 5. Some gas is trapped in a large syringe. The atmospheric pressure is 100 kilopascals. The gas pressure is 200 above atmospheric. So I know that that would make it 200 plus 100, which is 300 kilopascals. The piston moves outwards and the volume of the trapped gas doubles. Temperature remains constant. So this is basically telling you to use P1 V1 equals to P2 V2. This being the older pressure. However, it just says that the volume of the trapped gas doubles. So if I use this idea that I've also written above, P is inversely proportional to V. So if volume doubles, then I know that by inverse proportion, the pressure would half. So if you do half of 300, the answer for that would be 150 kilopascals. Let's go on. Question number 6. This is actually a bit more technical than it looks. Air is trapped in a metal cylinder by a piston. The piston is free to move. So this means that the volume can change. And the trapped air is at atmospheric pressure. So this air which is trapped is at atmospheric pressure. The cylinder is in hot water. The cylinder is taken out of the water and left to cool. What happens to the mass of air in the cylinder and its pressure as it cools? So I know for a fact that the mass of the air would not change. But what happens to the pressure of the air inside here, right? Now this is what we need to consider. So if this was just a case where the piston was fixed or it was a sealed container, then we can just say that since temperature is decreasing, the pressure must also decrease. But the idea here is that the volume can actually change, and it would change. The volume would also decrease. And the reason is this, that as the temperature is decreasing, you know that the particle's kinetic energy would decrease. So the volume would also decrease as this piston basically collapses inwards when it's taken out of the hot water, right? So, and basically also remember that the volume would decrease because of the pressure differences, right? So the air inside was initially at atmospheric pressure. Now, when all of this cylinder is taken out of the water, so the idea is that the pressure inside is also equal to the pressure outside. So in that case, the volume would actually not change, and that's why the pressure of the air also would not change, which means A is the correct answer here. So that's what makes this tricky, because basically the trapped air was initially also at atmospheric pressure. It's the pressure difference which drives the piston either inward or outward. Since the pressure difference is not changing, the volume would also not change, and the pressure would also not change. Let's go on. A gas syringe contains a volume V1 of gas at pressure P1. The volume is reduced to V2 without any change in temperature. What is the expression for the change in pressure? So change in pressure would be final minus initial. I know that the final pressure is going to be greater because the final volume is lesser, right? Because of that inverse proportion. So that would be P2 minus P1, P2 being the final pressure, P1 being the initial pressure. So initial pressure is just P1, and if I want to find P2, I can use P1 V1 equals P2 V2. So P2 would then become P1 V1 over V2, right? So P1 V1 over V2 minus, instead of P1, I'll write, what do you call it? Yeah, just P1. So that becomes option C. Let's go on. Question 8. Which statement about copper explains why it is a better conductor of heat than glass? So better conductor basically is determined from mechanism number 2 of conduction, which is free electron movement. Copper is a metal, so it does have free electrons, right? So that's the answer to this one. Next, an experiment is carried out as shown in the diagram. Why does the ice take a long time to melt even though the water at the top of the tube is boiling? Remember, in class we've seen a experiment exactly by this name. So water at the top here is boiling. This means this is 100 degrees Celsius. If ice is taking a long time to melt, so this is not melting, so it's somewhere around 0. So there's a temperature difference, but the heat is not being conducted from here to here, right? So that's because water is a poor conductor of heat. If we just heated it from down below, then there are two reasons that the ice would melt. One is that the flame is now in direct contact with the ice, and the ice would absorb that heat energy directly. So that basically bypasses conduction. The other reason is that the convection currents would also be set up as due to density changes, there would be a transfer of thermal energy, and that would also cause the ice to melt. So convection does occur in water. Ice is a poor conductor of heat. By the way, ice would be better than water because it's a solid, and the gauze is just there to weigh down the ice, to keep it down and to prevent it from floating, because again, if it just floats and comes here, it would again melt because of it being in direct contact with the flame. Question 10. Cotton wool is a good thermal insulator. It consists of many threads of cotton which are tangled together to make a material which can easily be pulled apart or compressed. The diagram shows the structure of cotton wool. Why is cotton wool a good thermal insulator? We've also been over these type of questions in class. That's because it traps air. So it traps air and prevents convection. 11. An electrical heater is placed in a beaker of cold oil as shown. The heater is switched on. What happens to the liquid at X? So as this is heated, temperature is going to increase. Volume is also going to increase as the liquid expands. Density is going to decrease and it's going to rise. So density decreases, so it becomes less dense and rises. That's the answer here. Question 12. The diagram shows the inside of a refrigerator. When the refrigerator is first switched on, what happens to the air near the cooling unit? So the particles do not become smaller. That's not what contraction means. The particles move closer together, and as they move closer together, so we know that for the same mass, the volume is decreasing, which would cause density to increase, which is option D. Now we are heading on to the structured questions. Question 1. A small aircraft takes off from the horizontal deck of a ship. Before taking off, the aircraft is held in place by a hold-back bar. When the hold-back bar is released, the aircraft is pulled along the deck by a steam-powered piston as shown in 2.1. So this is shown here. The steam exerts a high pressure on the piston. Explain using ideas about particles how the steam creates a pressure on the piston. So it's not asking about the variation of pressure with temperature or volume. It's just asking about how pressure is created. So remember that usually that question is for 3 marks. Here it's for 2 marks, but to be safe, we'll be giving the same level of detail here as well. So the first thing you say is that the particles, zoom in, So particles are in constant random motion, and the particles collide with the walls. Here it would be with the walls of the piston, exerting a force, and that basically gives rise to the pressure. Explain why the pressure on the piston increases as the temperature of the steam increases, right? Now this is the question which is asking for the variation of pressure with temperature. So we'll say that the average kinetic energy of particles increase, they move faster, and collide more frequently with the walls, exerting a greater force. Pretty textbook questions here. Next, when the pressure is high enough, the holdback bar is released. The steam pushes the pipe along. The steam pushes the piston along the pipe shown in 2.1. The piston has a cross-sectional area of 0.3 meters square. Pressure of the steam in the tank is given. Atmospheric pressure is given. Determine the resultant force caused by the pressure difference. Show your working. So let's look at the diagram for this. So on the piston, there is the atmospheric pressure which is acting like this. And because of these particles, because of this steam, there would be this gas pressure which is acting like this. Now here, which pressure was greater? So the gas or the steam pressure is greater than this, so I know that the resultant would also be outwards towards the right. So let me first find the pressure difference. That would be 2.1 minus 1 into 10 to the 6, so that is 1.1 into 10 to the 6 pascals. And then I can use the pressure equals to force over area formula. So the force is then the pressure difference times area, right? And that is 1.1 into 10 to the 6 times 0.30. We know that the direction of this would be towards the right, so now all that remains is actually just solving for this. So this turns out to be 330,000 if I'm not wrong. So 3.3 into 10 to the 5 newtons. Let's go on to the next question. So remember that this question we also did in class when we were doing the past papers. A copper saucepan with a wooden handle contains cold water. The saucepan is placed on a red hot heating element that is part of an electric cooker. 4.1 shows the saucepan on the heating element. Explain why wood is a suitable material for the handle of the saucepan. So that's because this is a poor conductor, or you can also say that this is a good insulator. Either or makes perfect sense. Describe and explain in terms of free electrons how thermal energy is transferred through the copper base of the saucepan, right? So how is that transferred? Now this is in terms of free electrons. Whenever such a question is asked, I know that both mechanisms would work, but I would just focus on the more dominant one, which because copper is a metal would be free electron movement. So you say this first point, first mark. So electrons gain kinetic energy at the hotter end. Next, you say that the electrons actually move, not vibrate, because these are not molecules. Electrons move from the hotter to the colder end. This is the second mark. And the third mark is for saying, and they collide with the atoms there, atoms or molecules there, transferring energy to them. right? So this is a very generic response that you would always have to say in questions like this. Describe and explain how thermal energy is transferred upwards through the water. Now, being transferred upwards is a hint that you have to talk about convection. So again, this is a 3-mark question. Always you'll have to write down more or less the same amount of detail. So first you say that the liquid which is heated, so the liquid which is heated expands. So here it's the water. So the liquid expands because of the increase in temperature. Then you say this, that this causes, because of the increase in volume. So remember, we talk about this in T, V, rho, and then rising or sinking. So this causes the density to decrease. The hotter water rises. So the first mark here was for any mention of expansion. The second one is for density decreasing and the hotter water rising. The third mark is for saying that the colder, denser water, so it's relatively colder, so it's relatively denser water at the top sinks. Even just saying this gets you the mark, but I'll just go further and say that this sets up a convection current. So that was the solution to this paper, which was not very difficult if you had understood how the questions in the class were done and the answering techniques. So like this video, comment if you have any questions or suggestions, subscribe to the channel for more content like this, and I'll see you in the next one.